Today we're going to continue solving with absolute value. Last class, we talked about how to solve equations when we're dealing with absolute value. Today we're going to go one step further and we're going to talk about how to solve inequalities. So you'll see that most of the process is going to be exactly the same. There are just a couple of extra special cases that we have to watch for, as well as just something that we have to remember to do as we're splitting up our two cases when we're solving. So here are the 5 steps that we're going to work through. We're going to start, let's just start with example number 1. So first step says we want to isolate the absolute value and everything in it. So here's my absolute value. I need to get rid of that 3. I need to send it to the other side by dividing. So we have absolute value of x is less than 8. So now that we have our absolute value isolated, we need to check for our special cases. So for inequalities, if we have a less than symbol, which we do, we're dealing with a less than symbol, we want to see if it's less than 0 or less than a negative, okay? And we don't have either of those. We have absolute value of x is less than positive 8. So since we don't have any of our special cases, we're going to continue moving on. And the next step is going to ask us to split it into 2 cases. So once again, we're going to split it into a positive case and a negative case. And we need to remember to flip our inequality when we make it negative. So just like when we multiply or divide by a negative value, when we change that solution to be negative, we want to make sure and flip our inequality. So here we have absolute value of x. So this is just going to be x is less than 8. And then for our negative case, I have an x and a negative 8. And we want to flip the inequality. So any value that is less than 8 or greater than negative 8 will satisfy this equation, or sorry, this inequality. Okay, if I were to graph this on a number line, let's just say this is negative 12, negative 8, negative 4, 0, 4, 8, and 12. Okay, so since I just have a regular inequality that does not have an underline, I have a regular less than and greater than, we're going to use open circles. Okay, open circle on positive 8, open circle on negative 8. Okay, I want values that are less than 8. So if you're unsure which way on the number line that goes, here's my inequality less than, and it's pointing that direction to the left. So from positive 8, we're going to shade our number line to the left. And then numbers that are greater than negative 8. So from negative 8, we're going to shade to the right. Okay, so we want numbers that lie within this range. So from negative 8 to 8, not including 8. Okay, if we were to plug in a value to check our answer, we could choose anything within that shaded region. So I could choose negative 4, I could choose negative 3, I could choose positive 1. I cannot choose 8 or negative 8. Okay, so let's choose 0. So if I plug in a 0, absolute value of 0 is less than 8. Whoops, that's not an 8. 0 is less than 8. So yes, that solution works. Okay, I could also check negative 8, and you'll see that if I plug in a negative 8, 8 is not less than 8. It's equal to. So we were correct in choosing the open circle. Okay, so this is your solution on a number line. If I wanted to write it as an inequality, I can have negative 8 less than x less than 8. Okay, example 2, I'm going to subtract 3 to isolate my absolute value. So absolute value of x minus 6 is less than or equal to 1. So now that my absolute value is isolated, I'm going to check, do I have a negative or a 0 on the right side? No, I don't. So I'm able to, at this point, split it into my 2 cases. So x minus 6 is less than or equal to 1. x minus 6 is greater than or equal to negative 1. Remember, we have to flip that inequality when we make the right side negative. Okay, going ahead and solving for x, I get x is less than or equal to 7. And over here on this one, I get x is greater than or equal to 5. So this one, when I graph it, let's just put some numbers on here. We have 2, 3, 4, 5, 6, 7. This one we're going to use solid points because I have underlines. We're going to put a point on 7, a point on 5. Okay, this one is also going to be in between because we want numbers that are less than 7, greater than 5. That falls in between. All right, now that we have it graphed, let's go ahead and plug in a value to check our work. So I'm going to plug in a 6. Remember, we plug into the original equation. So I have absolute value of 6 minus 6 plus 3 is less than or equal to 4. So absolute value of 6 minus 6 is going to be 0. And 0 plus 3 is 3. So 3 is definitely less than or equal to 4. Since this graph has solid points for the endpoints, I can plug in a 5 and a 7, and I should also get a true statement. So I'm going to just choose one. I'm going to plug in the 5. So 5 minus 6 is inside the absolute value. I have a plus 3 less than or equal to 4. So 5 minus 6 is negative 1. And then we're going to take the absolute value of negative 1. 1 plus 3 is less than or equal to 4. Okay, 4 is less than or equal to 4. So previously, when the numbers were the same, I just had a regular less than symbol, so they could not be equal. Here, since I have that equal sign underneath, they can be equal, and it makes a true statement. Example number 4. So this one you'll notice we're working with a greater than or equal symbol, which is totally fine. It's just going to make our graph at the end and our final answer a little bit different. Okay, so I'm going to start by isolating that absolute value, adding 10 to both sides. That zeroes out. So 2 times the absolute value of x minus 4 is greater than or equal to 12. Divide by 2 on both sides. Absolute value of x minus 4 is greater than or equal to 6. Okay, so now we have our absolute value isolated. I want to check for special cases. So since I have a greater than symbol, my special case with greater than, if it's greater than or equal to a negative. So this is not greater than or equal to a negative. We're going to continue solving this as is. So I have x minus 4 greater than or equal to 6. X minus 4, flip our inequality, less than or equal to negative 6. We're going to solve both of these inequalities. So I get x is greater than or equal to 10 over here. Add 4, x is less than or equal to negative 2. So I'm going to go ahead and draw my number line. And I'm going to just count by twos. Negative 4, negative 2, 0, 2, 4, 6, 8, 10, 12, 14. Okay, we're working with solid points on our number line because both of them are less than or equal to, greater than or equal to symbols. Now, when I'm shading in my number line, on my 10, my inequality is pointing to the right. So I'm going to shade away from the center. Okay, we want to also darken in our arrow to show that my values keep going, meaning if I plugged in a 20, it would work for this inequality. Okay, this one is going to the left. So I will tell you this, your shading should always go both of them towards the outside of your number line or both of them towards the inside. They should never be facing the same direction. So if they face the same direction, most likely you forgot to flip your inequality when you split up your absolute value. Okay, so your number line solution looks like this. If we wanted to write it as an inequality answer statement, you can write it as x is less than or equal to negative 2 union. So remember this from our domain and range on our rational function. And then we would say x is greater than or equal to 10. So remember, this symbol means or. Okay, you might also see it written as interval notation from -infinity to -2 with a bracket. That describes the left end of your number line. And then the right end of our number line, we're going to start with a bracket on 10. We're going to go to positive infinity and also include it with a union. Okay, your interval notation is probably how you're most likely going to see that written. But I wanted you to see where our inequalities match up to that number line as well. Okay, let's look at example number 5. So I'm going to go ahead and isolate this absolute value. So I have -3, absolute value of x is greater than or equal to 3. And then when I divide by -3, I find absolute value of x is greater than or equal to -1. So if we come up here and look at our special cases, you'll notice that if we have absolute value and we have a greater than symbol, we will always be greater than a negative, because as you recall from yesterday, absolute value makes everything positive. Okay, and positive is always going to be greater than a negative. So if you remember to look at your special cases, you're not even going to have to solve this inequality. You'll know that this is always going to be true. So you're going to be able to write your solution as all real numbers. Meaning you could choose any number to plug in. So for example, let's just choose a -428. So if I take the absolute value of -428, it's going to be +428, which is greater than or equal to -1. We wanted to go the positive route. We could choose +274. When we take the absolute value, we get +274, and that's for sure greater than or equal to -1. Okay, so if you look at your special case, when you have a greater than symbol and a negative, your answer is going to always be all real numbers. Okay, and then looking at the flip side, let's go ahead and isolate this absolute value. So we're going to multiply by -4 on both sides. Absolute value of 6 minus 5x is less than -28. Okay, so here we have a negative and we have a less than symbol. So coming up here, if I have less than and it's a negative or a 0 on the right side, we're going to write no solution. And here's why. Just like yesterday, absolute value could not equal a negative. Okay, here, absolute value is always going to be a positive number. We don't know what positive number is going to come out of that absolute value, but there is no possible way that a positive number can ever be less than a negative number. Okay, so we're going to say that this is no solution. So it's just really important that you're checking for your special cases prior to solving all the way through, because you will solve and get a value. It's just not going to work if you plug it in. Okay, so checking for special cases once your absolute value is isolated is going to be crucial, number one, to getting the problem right, and number two, to saving yourself some time.